In this video clip, we present in-place augmented reality, a new way for storing and retrieving augmented reality models. The details are given in the paper, while here we focus on describing the general approach and some examples. In augmented reality, virtual models are created by an artist and stored in a database. According to the context, the relevant model is retrieved from the database, registered, and rendered onto the scene. In many AR applications, using a database implies several difficulties. First, the database has to be queried for the required content before augmentation can start. Second, the content creator must not only store the virtual content on the database, but also publish printed material containing an index to the content. And last, database and communication increase the complexity of the infrastructure. These difficulties apply, for instance, in index-based schemes, where the AR system reads an index and fetches the content from a database accordingly. A possible way to avoid these difficulties is to fully encode the virtual content in a barcode. Although technically possible, no applications were reported that employ such a scheme. However, in both schemes, one issue remains unsolved. The printed code is not understandable to a human without using the AR system. In the in-place augmented reality scheme we propose, we embed a 2D, understandable representation of the content into a printed paper. When captured by a viewing device, the virtual models are extracted directly from the incoming image. Let's look at an example. This is a satellite image of the St. Moritz ski site in Switzerland. We added intuitive annotations for the skiing routes and the bus route in the area. When imaged by our system, the annotations are analyzed and animation is applied accordingly. In addition, we embed an elevation map of the terrain at the top right corner to represent the geometry of the terrain. Let's see the combined result of applying the embedded annotations and the geometry. The key difference of our scheme from encoding content in barcodes is that the embedded virtual content is understandable to a user who views the image without an augmented reality system. When viewed using the AR system, the content is further enriched. We refer to this feature as dual perception. Let's take a look at the process pipeline of an in-place augmented reality application. First, a dual perception representation of the model is created and printed. In runtime, the printed representation is acquired by the AR system. The virtual models are then extracted from the acquired image as a one-time step. In every frame, the virtual models are registered onto the scene and rendered. Let's look at another example. Here, we demonstrate interactivity using our scheme. We embed a boat object with hand and wave annotations next to it. The hand annotation is used to tell the in-place augmented reality system to wire the keyboard arrows to the nearest object, which happens to be the boat. The wave annotation tells the system to apply geometry modification to the model around and animate it as a wave. And finally, layering of information can be used as well. In this world map application, a view of Earth is printed with different layers representing the terrain elevation, average temperature, and population density. Here we can see the Far East area with the Himalaya mountains in the middle. Toggling the layers on and off, it is easy to infer that in areas of high altitude, the average temperature is colder and the population is sparser. Note that the entire model was acquired using a simple webcam and that no database was required. Thank you for watching.